Today, lesson 19A, solving two-step equations. We've spent the last couple of days solving one-step equations. They were called one-step equations because it only took one thing or one step to solve them, whereas today it takes two things or two steps to solve them. And we'll work a little more on writing equations from word phrases and then our typical why am I learning this. And I'm just holding on for a second so that everybody can get what they needed to get written down. All right. So these are the things we've been working on the last couple of days. Problems or equations where we have to add or subtract the same number to both sides to solve. In this one, the inverse operation to subtracting 8 is adding 8. We also talked about the fact that we could use the additive inverse property and try and make 0 there. We also tried to talk about the fact that you could just look at what's inside the yellow shape there and make sure that those two things were opposites of each other. Anyway, whatever it takes for you to understand that you need to add 8 to both sides. And then negative 26 plus 8 is negative 18, so the solution is y equals negative 18. And then the problems from yesterday, like this, 7y equals negative 91. We talked about the fact that the inverse operation to multiplying by 7 is dividing by 7. We also talked about the fact that you could think of this as the multiplicative inverse property. In other words, trying to make 1 right there. Either way, doesn't make any difference. But the idea here is that we need to realize that the solution is y equals negative 13. Okay, two-step equations. These are equations that require two steps to find the solution. So we're going to deal with these in two different ways. We're going to start with manipulatives and then we'll go from there. So here's a picture that is represented by that equation. And once again, that equation that you guys have in your notes is 3x plus 1 is equal to 7. And here are the three x's. Here's the 1, and these are just tiles. These are x tiles. This is a unit tile, and here are 7 unit tiles. And what we're trying to figure out here is we're trying to figure out how many of the unit tiles go evenly with each x tile. So in order to get that to a situation where it would be easy to figure that out, we would need to, first of all, somehow get rid of that 1 unit tile right there. So in order to do that, we would need to put a negative unit tile right there. And if we do that on the left side, we also have to do that on the right side. So in this situation right here, what does this make right here? What is that called? Okay, what's it also called? Well, it's also called a unit or a 0 pair, right? 0 pair right there and a 0 pair right there. And so what happens is we can take those away because they made 0. And so what we're trying to do with manipulatives here is we're trying to figure out how many of the unit tiles go with each of the x tiles. So how many of these unit tiles over here, how many of them would go with each x tile if you did it evenly? How many? 2 of them. So with this unit tile, or x tile, we have 2 unit tiles. With this x tile, we have 2 unit tiles. And with this one, we have 2. So what happened here is after we subtracted 1 or added 1 to both sides, we had 3x equal to 6. And then we can see that going in evenly 3 times, we have x equals 2. In other words, each of the x tiles represent 2 unit tiles. So let's go through and actually show the steps on that. So for this, you need to make sure you copy down all of the steps in your notes. What we did with the tiles is we added a negative 1. In other words, we subtracted 1 from both sides. Write that step in your notes, please. And once we did that, over here, we got a 0 pair right there, which is one of the things we've talked about with the one-step equation. So that kind of disappears because of the 0 pair. Use the additive inverse property is another way of looking at it. So on the left-hand side we have 3x, and on the right-hand side 7 minus 1 is 6. And now we have one of these one-step equations that we learned how to solve yesterday. We have 3x equals 6. To solve that, we would need to divide both sides by 3. Why division? Because that's the inverse of multiplication. So we end up with x equals 2. All right. And so, there's really two different ways of solving these types of equations, a hard way and an easy way. So everybody make sure that you're looking up here. Some people make the mistake on the left-hand side and they try and do the inverse of the multiplying and dividing first. Now watch what happens if you try and do that. This thing gets messy in a hurry. And the reason is because of the fractions in there. We still end up with x equals 2, but it gets messy. Now watch on the right-hand side. If we deal with our adding and subtracting part first, it makes the problem much, much easier. Which problem looks easier to you, the one on the left or the one on the right? It's obvious. And so my point here is this. If there is adding or subtracting in the problem, which there is right here, you make sure that you always deal with the adding and subtracting part first. It makes those problems much, much easier. Okay, so much like the last 2 days, the idea here is to get the variable by itself on one side. Make sure that you always perform the same operation to both sides, and this is where you're supposed to be filling some things in. Always make sure you undo an operation. In other words, you perform its inverse operation to both sides, and it's always easiest to undo the addition or the subtraction first. All right, here is number 1. We have 2x minus 5 equals 19. So I'm going to do this one the same way that I did the very first one. We'll look at it first with manipulatives here. So here we have 2x's right here, and it was minus 5 and equals, how many were there again? 19. A lot of unit tiles over there. So here, once again, here's what we have. We have 2x, minus 5 equals 19. So what we need to do is we're trying to figure out how many of the unit tiles go with each of the x tiles. So what we need to do to make that happen is we need to find a way to get rid of all those negative unit tiles. Anybody have any idea how we could do that? Okay. So what we want to do here then is we're going to pull in 5 positive unit tiles, and that will get rid of those. But if we do that on one side, we also have to do that on the other side. So let me do that here first. And once again, these are making 0 pairs, but I also have to pull in 5 of those. 2, 3, 4, and 5. Now, what can I do with all these right here? What's that? Get rid of them. They make 0. So let me go ahead and quickly pull those off. While I'm doing that, how many unit tiles do I now have on the right-hand side? 24. The 19 plus the 5. So I have 24. Right now I have 24 of these unit tiles, and I have 2 of the x tiles. So we're trying to figure out how many of the unit tiles go with each of the x tiles to make sure that they each have the same amount. How many unit tiles go with each x tile? 12 of them. Do we all see that?
Yes.
Is it easy to see?
No.
Is it easy to see from this mess right here?
No.
No. Is it easy to see when you have this right here?
Yes.
Okay. The point I'm trying to make here is that sometimes teachers use manipulatives quite a bit to try and solve equations, but I think that it's easier if we actually use our head and use a little bit of math. So we're going to get away from this idea of manipulatives right now, and let's just solve this thing using some algebra. So what we did was we added 5 of the unit tiles to each side. So that's the same thing that we're going to do here. Let's add 5 to each side. And we made our 0 on the left-hand side. So on the left-hand side, we're now left with 2x. On the right-hand side, we have 24. And when we did that, that was the inverse property. Or we can take a look at those and make sure that we made the opposite right there. And then to finish this, the inverse of multiplication is division. Or we can think of trying to make 1 right there, which is the multiplicative inverse. And either way, we're going to get the solution of x equals 12. Okay, I want all of you to try number 2. Lots of excellent work. I'm going to make a mistake on purpose. And the reason why I'm doing this is I saw 1 or 2 of you do this. So please raise your hand when you see where that mistake is. Okay? All right, I need to subtract 1 from both sides. That is the inverse operation to adding 1. Remember, we always want to deal with the adding or subtracting part first. We made our 0 right there, which is good. So we are left with negative 8x equals, and then we have 25 minus 1, which is 24. Then the inverse operation to multiplication is to divide. And so I divide both sides like that, and I end up with a solution of x equals 3. And suddenly a bunch of hands went up. This is what happens when you're not totally paying attention to what you're doing. Okay? What's wrong?
The negative sign on the 8.
I have a negative sign on that 8 right there.
Second.
Ah, there we go. And what happens is, instead of the answer being, or the solution being x equals 3, it should be x equals what?
Negative 3.
Yes. Question?
Why is it subtraction?
Okay, subtract 1 from both sides. Make sure those two things are opposites, or make sure we're creating 0. Then divide both sides by negative 8, and the solution is x equals negative 3. So that's pretty easy as long as everything is nice and lined up for us. But sometimes we start flipping things around, and some of us aren't sure quite what we're supposed to do. So let's take a look at number 3. Any ideas on what we should do first in this one? Okay, quickly, turn to your shoulder partner and discuss what you think you should do first. Okay, so once again, I heard add negative 15 or subtract 15. Both of those things will do what you need to do. So let's add negative 15 to both sides. If you wrote subtract 15, that represents the same thing. And the reason why that works is because over on the side where the variable is on the left-hand side, with the adding or subtracting part, we made 0, which is what we're trying to do. Or, as we found out a few minutes ago, that we're trying to make sure that those two things inside the yellow are opposites of each other, and they are. And since that makes 0, that's now gone. On the left-hand side, we now have x over 3. On the right-hand side, 6 plus negative 15 is negative 9. I will let you finish that one. All right, back up here. Once again, I'm going to make a mistake on purpose. Please stop me whenever you see what that mistake is. I'm going to make a mistake on purpose. This is a very common thing. So many of you have your hand up. Is it not obvious that I've made a mistake there? Yes or no?
Yes.
Okay, Jermaine, what's the mistake?
That you're already dividing, so you need to multiply.
And I like the way you said that. There's already division there. Why would you divide again? Look, that means division. That represents division. X over 3 is x divided by 3. So you don't want to do that. You want to multiply both sides by 3. And we end up with x equals negative 27 for the solution. And right there I'm trying to show you that when we do that, we're really making the 1 that we want. 3 over 3 is 1. Okay, solution of x equals negative 27. I need everybody to please do number 4 and number 5. Okay, number 4. We had x over 5 minus 4 is equal to 3. We deal with the adding or subtracting part first. We have subtraction of 4 right there. We need to do the inverse to that. The inverse operation to subtracting 4 is adding 4. The check is making sure that those two things are opposites of each other, or in other words, that they make 0, which is an example of the additive inverse property. We did that. So now on the left-hand side we have x over 5. On the right-hand side we have 7. Now it's a one-step equation like yesterday. X over 5 is the same thing, or very close to the same thing as x divided by 5. The inverse to dividing is multiplying, so we multiply both sides by 5, and we get a solution of x equals 35. Number 5. We have 10 plus 3x is equal to 40. We deal with the adding or subtracting part first. We have 10 plus 3x. So we're trying to make sure that we do the inverse operation of something plus 10. And that, of course, is to either add negative 10 or subtract 10. I'm going to subtract 10. The check is making sure that those two things are opposites right here. And they were. Or in other words, they made 0. And so on the right-hand side, I have 30. On the left-hand side, I have 3x. And now it's a one-step equation. 3x is the same thing as 3 times x. The inverse to that is to divide by 3. We do that, and the solution is x equals 10. Are there any questions on what we've done so far today? Tomorrow, we will put the finishing touches on this idea and go through it in full detail. And so we are finished for today.